So far, we have talked about waves interacting and described how they interact, but we haven't been precise about how they do this and the results of this interference. If we have coherent sources of light, we can easily see how waves interfere with each other. Young was a scientist who first demonstrated a practical test for the wave nature of light by producing and explaining an interference pattern using two slits of light. Today we can do this experiment much more accurately using a laser, as it produces coherent light and does not scatter as much as non-laser light. We pass laser light through a slit. The slit is narrow enough so that the laser light undergoes diffraction, discussed separately in another podcast. The diffraction spreads out the laser light so that the wave fronts are curved. If we introduce another laser in the same arrangement and place it in front of this laser, we can see that the pattern of light in front of the lasers changes. Before the light was spread out uniformly, now the pattern has formed lines of blackness and intensity. This is due to the interference of the light waves. When a wave and another wave pass over or through each other, they interfere with each other. Remember, a wave is a particle moving up or down in a medium. The wave makes the particle move up or down as it passes over the particle in the medium. When a peak moves over a particle, it causes the particle to move to its maximum positive displacement. When a trough moves over a particle, it makes it move to its maximum negative displacement. So, if two waves move over a particle, one which makes the particle move to its maximum positive displacement, and one which makes the particle move to its maximum negative displacement, they will cancel each other out. If both waves supply the same force to the particle, but in opposite directions, the particle will remain stationary. This will appear as a node in the combined stationary wave. If, however, one wave had a greater amplitude than the other, then the particle would move in the overall direction indicated by the addition of the amplitudes. If two waves pass over a particle and are both peaks or both troughs, then their forces will combine to make the particle move twice the distance it would have moved with just one wave. This is the nature of destructive and constructive interference. When two waves cancel each other out, we have destructive interference. When they add to each other, we have constructive interference. In the interference pattern before, we have places where there is constructive interference, the brighter spots, and destructive interference, the dark spots. When we take one source of laser light and pass it through two slits to produce two diffraction patterns, we can say a lot more about the nature of the interference pattern.